Alright. Is the audio working? I don't think the audio is working. Hang on, no, the start of this album is just really quiet, so let's push that away so my volume's a little more reasonable. Okay, so I have acquired in my infinite, let's go with infinite childishness, because that seems to be pretty accurate. These two odds and ends. This guy you might not recognize. This you definitely won't recognize. Some of you may recognize this. It is the DPS series of programmable DC-DC power supplies that happen to be really good for building, the idea is all those bits in one place all together. Hang on. I kind of misnamed that, didn't I? All mashed together so that you can have programmable power supply. And I don't have one of those right now, and I would like to be doing more electronicsy things. So I've got this doing some other stuff for work, the 3D printer rather. Is it actually extruding? Yes, it is extruding. We're good. And I got the, up over here, I've got the Octopi Cam, so we're kind of set there. Via Luna, which is what we're listening to right now. Their first album, Calm and Clear, followed by Heavy Light and Wilt, is what I'll be listening to the next 2 hours-ish. Let's see, what else? Forgetting anything? Oh, goodness, I don't know. Probably forgetting something. So, the goal is to get broad strokes fleshed out for a case for all the bits and bobs and odds and ends. So, I have the parts. Now I just need to have the thing they go in. And in my infinite wisdom, I have decided to do this stream after realizing that I left my calipers at work. So, whoops. So I had to do this with a tape measure with just millimeters on it, which is going to be fun. Yeah. I think that's everything. So, oop, I just realized I don't have chat open. Hang on. Pop out chat. Move stuff around. Yep, just that in the middle there. Cool, yeah, alright, I think that's everything. So, first up, I need... Well, I guess I kind of need mocks of these guys, so... Rectangle, about 33 millimeters high. Well, it's roughly 33 millimeters high, but it's, there's other important dimensions too. Like, for example, hang on, is it still inches on the bottom? My god, that's annoying. It's 11.5 millimeters, or 11.5 centimeters across, and 65 millimeters down. What did I say? 32 to the bottom of the PCB. Yeah, plus like a little bit of stick out. This will not be UL listed. I'm going to explicitly make sure that this never gets UL listed, and that it catches fire if anyone brings it into a building that has UL listing. What's the fun in safety, anyway? Safety schmafety. Says the guy who gets paid to design safe things. Okay. Oh, why did it not give me a length there? Because it didn't pick anything. Okay, 32 millimeters. Let's do... I'm gonna guess... Yeah, no calipers makes this real fun. Looks like about 105 millimeters. And that looks like about square. So I'm just gonna kind of wildly assume that I can put... Let's do this and this. Make these guys construction. Whoop, hang on. Did that slightly wrong. Printed TPU. Yeah, I would like a giant squishy power supply. Brilliant. You know, maybe you could still make something that's UL listed and like safe with that, but I am not going to be the guy to try. Anyway, 105 millimeters across. Just going to kind of assume it's the same. So that'd be 55. That looks like... Oh, I don't know. M6? I'm gonna have to go back I think, come up with better numbers for all of these. No, hang on. Really? It's that big? It's smaller than that. It's more like 5 millimeters. Yeah. Okay. Features. Extruded cut. Not the right way to do this. Don't care. Through all. Still don't care. Okay. So. Whoops. Hang on. Get that out of the way. You didn't see anything. 21 of 60. Man. Getting right along. For myself, so we'll call it Quick Schaefer and DPS5005 case. And this is going to be the ACDC, and I'm going to have to actually put everything in a model. So, model. This is going to be the. You know, there was a name for this. I feel slightly inclined to go look up. Not going to show my Amazon history on screen, just because like it's a generally bad idea. And wow, it's called just a 36 volt 5 amp. This was a thing I bought, by the way, a 36 volt 5 amp, 180 watt. So plenty of power. I will never want for needing to probably light everything on my desk on fire, which is good. Wall front. It's kind of have like a model number or something, but I guess we don't get that. So we're just going to call it what it says on the tin. DC 36V-5. DC 36V-5. I'll call it Mach too, just to be extra sure. Now we need the DPS, which is going to be... So this is the shell, which is all that I really care about, because I care about interfacing to this. It's probably going to be like this extruded around the back, and then like a lip around the front. I don't have to figure out like what these little tabs do, but you know, that's what it is. It is what it is. Just wing it. Hang on, did I make that in inches? No, it's in millimeters. Thank goodness. All right, top plane. Just keep grabbing the power supply, not the shell. $72.5. Oh, you know what? I can just measure across the top. Because that's going to give me a better number, maybe. Probably not, but... Electroninator. Yes. Always pray the platypus. So what do you got? 79 across the top. Oh, I'm doing this in the top plane. I'll fix it later. 42? 43. It's kind of a weird set of numbers. We're going to do this one as a thin extrude. Of like... Oh, I don't know. 2 direction... 2.5... Ooh, I can do it bidirectionally, actually. That's kind of neat. How thick is this front plate? Roughly 2 millimeters? I wish I'd grab my calipers. 2, and we'll make this one like 4. Oh, no, actually, it's only one direction because I measured the outer dimensions. So we'll make that like 5. And then we'll say extruded plane on the top plane. Gotta kind of guess. Let's see. 72 by 39. 72 by 39 by 23. Oh, and it's a millimeter thick, roughly. Extrude base. I'm patient. Lined. 23. Thin feature, so we get the shell wall. Don't have to shell anything. Flip it around so it's on the right side. There we go. There's our mock DPS. I'll still have to figure out the mounting tabs that go on the outside over here and here, but that's for later. DPS 1005 shell mock. Maybe I will care about the electronics eventually. In fact, it wouldn't be a bad idea to right now. That's 34 millimeters thick. And this bit in the core here. Oh, come on now. This faceplate in here is kind of, sort of. Oh, come on now. It's supposed to be removable, but if you're a dunce, then you will have some issues removing it. There we go, faceplate. So, 34 millimeters back from... This is roughly a millimeter thick. Oh goodness, I don't remember which way's up now. Hey, no, I can figure this out. Yes, okay. That back in place. It's important. So now we come back here and say we've got a board. Is also centered. And 68 by 36. Oh, we're already on the bottom. Convenience. I say 68 by 36, I think. 68. 36. Features, extrude. Use a couple other tricks. So we have 34 thickness. Go the other way rather. And offset of 1 millimeter to account for the screen in the front. Quick mock. Nice. Oop, and I did everything in the wrong plane. Front plane. Just gotta shuffle some stuff around. Front plane, front plane, front plane. Whoops. Right click, edit sketch plane. And then assuming you assign things to the right planes, stuff just... Oh, whoops. I put that on the right plane instead of the front plane. Front plane. Nope, still wrong. What? Why is that rotated? That shouldn't be rotated. Okay, 68. 36. Yeah, I don't know how it did that. It probably shouldn't have done that. And this one, this back shell, should be a merging feature. So now I've got two bodies. I have the shell. Actually, I don't even need to call it the shell mock. It's just, it is the mock. Ooh. Temporarily renamed document? What? Okay, yeah. Update where used. That's fine. There are no references. Come on, I'm not that sophisticated. Now we've got both of our power supply bits. Power inlet module. Yes, I still have it. So ages and ages ago, I purchased some of these. Wow, educational version figures. I purchased some of these modules and I went and found a model on GrabCAD, I think. So I'm just gonna save as this guy. Look at all that. Look at all that detail that is just completely wasted on me. Projects 2021. Model, power inlet module. Ooh. While I'm looking at this, include all reference components. I know it's super low contrast. That's Windows' fault, not mine. Well, actually, it looks like it might be PDM's fault because it's not dealing with the dark mode. Whatever. Oh, you can do complicated prefixes and suffixes. Interesting. Okay. Whoops. Save as and include all reference documents. Yes. Add prefix. Save as, copy, and continue. Actually, don't replace. Just save as. Wipe everything. Or better yet, put it in its own subfolder. Power inlet module. So that it doesn't gum up my main. It's got to open everything, resave it. It's all educational, which, oh, you know what? That might curse my top level. That'd be annoying. I guess I have to make an assembly and see if putting the student file in the main one is going to break things. I bet it probably will, but I'm going to hold out hope that it won't for at least a little while longer. Oops, accidentally minimum distance. If you do minimum distance, it just does like, okay, edge of that circle to edge of that circle, and it computes everything for you. Don't want to do that. Want to have center to center because that's what actually matters for bolt patterns. So 55, 105. Time to bang it out. All right. So we need a control sketch from the top plane. I need to say I'm going to have my input up here, or rather my control module up here. It's sort of where it sits. I'll make these all construction. Make some stuff linear, or collinear rather. Alt L. Gotta have the power module back here. Gotta have the power entry module over here. Okay, that all seems pretty reasonable. Then I gotta have a box around all of it, and I'll do that with the center rectangle so that it always stays in the origin. Because I'm picky, I guess. Ooh, let's be a little more careful about that though, and instead of having it use those cross beams, I like doing mine with lines that have vertical and center, like vertical constraints, and then constraints to midpoints of lines. That way it's really obvious and clean, and you don't have sort of extra lines moving around in weird directions. Now, I want this to be... How do I want this to work? So I know I have... This is going to be 35 mils high. This one is going to be... We'll go take a quick peek at the inlet module. This is 72 across. 72. And this guy is going to be 115 by, what was it, 65 I think is what I said earlier. Ooh, and I closed that power inlet module that I just had open. I'm going to end up probably not putting this into my assembly because it'll break things. Oh, and it uses screws too. Right. Right. Okay, 47 by 17 and a half. I think it has snaps in it too, so that it snaps into place, but they aren't modeled in this one. Oh, I've got it snapped into a piece somewhere behind me, but I'm not going to go find it. We're just going to go with 47 for now. Ooh, and actually I need the depth. So 47, rough depth. Well, we'll do it from the plastic and just sort of try and keep track of how much space I need to leave. So 17 and a half. 17.5. And 47. Wow, that's a lot smaller than I thought. Maybe it just, this needs to shrink a lot. Condense this model a little bit. Ooh, I do need to have some sort of planning ahead for... So these are what the binding posts look like. Little standard run-of-the-mill Chinese 5-way binding posts. They are roughly 15 millimeters across. Back from the front face, they extend roughly 25. So we'll just do that for now and call it good. 15. I'm also realizing as I do this that I'm sort of conflating where I'm placing things. And I'll need to think about... Okay, let's assume... Ooh, you know what? Better yet, rather than having lines there, select midpoint, select origin, vertical. Select midpoint, select origin, horizontal. No lines, still constrained. I don't do that very often, or I used to do it a lot in the past because it's great for having a very clean sketch and not having extra things that you don't need. But if anyone needs to come along and look at your model later, it's not obvious how you're constraining it. I mean, they might be able to figure it out just based on how things are centered around the origin, but non-obvious constraints can be a pain. So we're going to offset this and say, let's say 5 millimeters wall thickness for now. Wow, that looks skinny. Okay, 5 millimeters. Ooh, boy, that looks skinny. We want... Let's see, how much is 5 millimeters? 5 millimeters is a lot. Go with 3 millimeters spacing to the walls. And that'll fit that board in place. We want this board located here, or rather that piece located there. And we need at least some distance back from the edge. So from this edge, it's 5.5. So we'll say we want this probably 10 or 15 down. 10's probably enough to fit the fastener in there and give myself a little pocket to screw into. Then if we come and look at this again, we've got back 35 millimeter depth, 72 millimeter width, and that is going to sit up here on the front. Whoops, accidentally exited the sketch. I guess the question is how far over... I need to leave it at least this distance over because the hook that sits in here, which I'll show you for a sec, this little tab, hang on, how am I going to be able to show this? This little tab right here is what snaps it into place, and I need to be able to make sure that I'll be able to use that later when I fix this model so that it's a little more accurate. If I had calipers, it'd be really easy to fix right now, but for now, we just need at least 3.5 millimeters clearance. We'll give it 5. Because not only do I need to have enough clearance for the snap, I have to have enough clearance to get a screwdriver down there later if I ever need it. So, well, let's make it 8 even. So then we got the binding posts. What I'll do is I will make some lines. And I can tell the binding posts I want them to be symmetric because I've selected a construction line and 2 regular lines, symmetric, and they will always space themselves neatly in between, sort of in the solid part of that face. So that makes them nicely constrained. Okay. Gonna add a quick separation in here. Something to give me a little, it's not gonna be really considerable isolation, but it'll be enough. Just a little bit of interference, really. And now that I'm looking at this, I actually have a lot of room in here to fit an ESP32 up against the roof. That'll be more obvious as I get deeper into this, but, whoops, hang on. Come on, power trim. Power trim. Oh, it did that in a screwy way. Hang on. Come on now. Play nice. I can't totally, like, rub it right up against the bottom of this guy. Like, this, I have clearance. This clearance here is going to be here-ish, roughly. But I don't really have that clearance down here, so I want more like... let's say a centimeter at the bottom of the board. Make that a centimeter. Quick note about construction lines. Those of you may have noticed that the construction line, the dimension did something kind of funny when I dragged it up a little bit high. If you go between a construction line and a regular line, you can use the construction line like a center line. Super handy for mostly cylindrical things, figures, or places where you're doing lots of revolves. Let's see. I'm gonna do something a little bit cheap here. I'm gonna add a line here and a line here, and because this line's length is already defined by this offset, pick that guy and say equal, and it'll space itself out. Now looking at the backside of the DPS, oh man, the more I look at this, the more I realize I'm gonna have some problems with thermals, so I'll have to take care of that eventually. Maybe just a fan right up here so that it blows air down into the back of the DPS, and yeah, that's gonna be what I'm gonna do. There's a heatsink. If you look at the top of the DPS, there's a heatsink right along the top here, and that heatsink lives right about here, which will be perfect for just dropping a fan over so I can blow down into the enclosure. Assuming this ever sees any high power, which it really should not. Okay, so now I've got... Let's make this... Oops, hang on. Nope, don't put a value there, please. Now I need to put a length on that. Say 40. Boy, that's going to be compact. Possibly, we'll see. And then I need some sort of gap. 30? Let's say 35. Yeah, okay. Is that still... Nope, that is not. Okay. So, minimum height has to be able to fit everything. The tallest component is roughly... Actually, how tall is this? This might be the tallest component. Oh, only 27. This is only 39, so probably a minimum of... Probably about 2 inches. And if we come and look at the power supply, that's only 32 millimeters tall. So, for right now, I'm thinking kind of a... Let's say 45 for right now. 45, mid-plane. Only this contour, please. Yeah. Cool beans. Extruded boss. Put this guy. Ooh, I can even come back to... Hang on, what's not defined about this? That's fully defined. What are you on about? Build. Drag stuff around. What did I leave undefined? Save. Electronics reference. Whoops. Still in the wrong. Hang on now. It went and found the wrong folder. We gotta save too. Enclosure. That's solid parts. Okay, what is... What is... What do? Why is something not defined? Oh, hang on. Figured it out. This line right here. Because he doesn't have a defined endpoint, he can be as long as he likes, and he's not construction geometry, it'll make it throw a fit. Sketch and rebuild anyway. I don't care. Cool. Okay. Built. Who's messaging me? Quick check. Oh, it's just my phone complaining. About being too charged. Which is fair. Yep, okay. Like that. Discharge normally for a little while. Extruded boss. Ooh, right. No, I was going to use this sketch. Extruded boss from this guy. Not thin feature. You know what? Nah, I'm not going to do that. That's entirely too convoluted, I think. So, we're just going to do extruded boss from this. And whoop. Clicked somewhere wrong and it didn't want to do anything. If you click a face, if it has an external bounding and if it's flat and has one single external boundary, it'll just do that instead. So, need to do a quick show of this sketch, or actually, not yet, but I need to use... I do want to merge result eventually. But if I come back to this sketch, I can say Here we go. D9 at sketch 1. You are now thickness at sketch 1. So now I want to come up here. I edit this feature. Learn to spell thickness at sketch 1. Yeah, boy. All right. Extruded boss, same thing. Click the face. Whoops. Click the face. Don't do it too quickly. Convert entities. Extrude. Thickness at sketch 1. And we'll call this the control sketch. And initial walls. Top closure, I guess. Bottom closure. Cool. Now we can do a quick, oops. Yep, it's an enclosure. Okay, next is probably using this control sketch. I can cut, let's see, pick that point and select, ooh, actually I can just pick the point and the line. I can say, oh, come on, point, line, midpoint. And now it'll be centered right on the surface. Pick this one, I can say midpoint, and it's just the same width as it already was. Now I have to define, of course, the height of the cutout, but 39 millimeters. Top and bottom edge, 39, extruded cut, and up to next. Boink, cutout. Ooh, actually, here's a good thing, because the next one I want to do is the 5-post standard test point distance. No, hang on. Standard multimeter test point distance? Okay, binding post. Binding post reading time. Okay. I think it's 3/4 of an inch, which is 19.05 millimeters. Okay. In order to permit the use of double banana plugs, the most common distance between the centers of the plug should be 3/4 inch, about 19 millimeters, which originated on general radio test equipment during the 1920s. Wow, that's a century old. Wow. Alright, so. Now I do... I think my scientific wild guess for this earlier was M5. So we'll just repeat that. We'll say Ol Wizard. And we're doing anti-metric. Sure, I guess socket head capture clearances. Oh, well, it's a counterbore. Whoops. Or I had selected counterbore by accident. But if we do screw clearances, then it's just per standard threads, which is just M5, if I could click what I wanted to the first time. So, I've got 2 of those. Connect them with a line. Control-C, or Alt-C, Alt-V to align them. And now I have to... Well, okay, there's a couple of courses of action here. It doesn't want me to pick the line that's lined up here. Annoying, but... what I can do is, since we're sketching on this plane, I can pick that point, I can pick this line, even though it's not on the right plane, and say midpoint. Lines are right up. And just go back to not through all, just up to next. Don't need to get overzealous with it. Yeah. Cool beans. Cool beans. Cool beans. Ooh. I think I want to print this in 2 halves. Like, I want to split this down the middle and have sort of some connecting features that bolt it across. I don't know how I'm going to do that yet, of course. And maybe I need this, this needs to be more like 50 millimeters, but... Yeah. Yeah. Oh, no viewers. Well, to those of you watching this later down the line, thank you. Okay, power inlet. We've got a cutout in a funny shape. It's 46.9. Wait, is that a round number in inches? It's not. Okay. 47 millimeters by 27 millimeters. Extruded cut on this face. We're gonna go. Ooh, here is a really good use of this particular style of thing. Chamfers, chamfers, equal distance. Okay, it doesn't do them both at the same time, but, you know, better than not having it. It is 6 millimeters. Okay. Wait, is that right? Yeah, normal distance, 6 millimeters. dy, 6 millimeters. Check the same thing on the bottom. 6 millimeters. Okay. So, 6, 6. It was 47 by 27, something like that. And because I put this line back here earlier in the construction sketch, I can select its midpoint, or no, I can select this point actually, and I can come back here and I can say midpoint. And that lines it right up. Extruded cut. And to next. Oh, I suppose I did miss these fillets. Let's be cautious and have fillets. 2 millimeters. Edit sketch. Fillets. 2. Yeah. All in one go. So we got top closure, bottom closure, DPS cutouts. Oh, M6? No, those were M5s. Dirt. I can click buttons correctly. I'm real good at it. 5. M5. Binding post holes. That's what they do. Gotta post hole. Let's see, what did I call this? It was like the power inlet? Yeah, power inlet cutout. Yeah. That is startlingly simple. I almost want this to have a little more space this way so I can set the ESP up in there nicely. Handy. I was hoping you had an ESP that was not in use, but all of mine are kind of attached to things, so I'm just going to pull one out of the bag. That's kind of amusing. Okay, so put those headers back in the bag. So I don't need them. It's not yet anyway. I'll probably end up soldering this one in place, but this little guy is 34 by 25. So I'm going to go back into the control sketch and say, where can I fit a rectangle that is 34 by 25? The answer is pretty much anywhere. Ooh, actually, I think I want it pointing the other way. 34. And you should be kind of up against the wall here. Where do I want to put that? I think I'm going to be crafty again. I'm going to make a symmetrical constraint. Alt S. Whoops. Come on, symmetric. Thank you. Yeah. I can have the ESP just sort of poking out of the side here. And I can have all the pins shrouded, so... Well, I mean... It won't be the world's safest thing, but it'll be fairly safe as long as I'm careful about where I'm routing the 120. I should think about how I'm going to put this together now or later. Let's pull this wall back a little bit. Make this more like, instead of 35, maybe 50. Okay. Sketch. Front plane. I would like to hide that sketch for starters. That's kind of in the way. I need a symmetry line here. And I need sort of a surface that I can use to split things. Make that tangent so everything lines up nicely. Make this equal to thickness at sketch 1. What? Oh, it's not sketch 1 anymore, it's control sketch. Make these equal. Make those equal. Why is this saying that it's not positioned right? Oh, okay, hang on. I need to have... This needs to be evenly spaced between these two, which means I need two sort of fake lines. No, vertical, come on now. I need two sort of fake lines if I want to place my split line nicely. Make that one construction for just a bit. I can use that to make those symmetric. And now I have a fully defined split line that will run exactly between my two important components. So I can print it in two halves pretty nicely, I think. And I don't have to worry about, like, hypothetically I could split it right here, but then I have to worry about how I'm going to make sure that the DPS stays in place, and that could be a bit of a concern. So, select chain, pick line, mirror, yeah. Features, actually surfaces rather. Extruded, through all, direction 2, through all. Split, split line. No, I do want full split. Trim tools, this one, selected bodies. Cut. Do not consume cut bodies. Ooh, maybe I need to intersect actually. Intersect. Do not merge result and do consume surfaces. Now I can hide one body and have the other one for free. Ooh, I could be even cleverer and I could say, instead of a surface extrude, well, I think I do want to leave that surface body, but what I'll do is I'll thicken it and I'll say 0.1 millimeters. And I think, oh yeah, that tries to merge and it breaks things. Don't merge, don't do that. When we come down to the intersect, it'll break because it doesn't have its intersecting thing. But if we put that in there and say intersect, get rid of all this silly stuff in the middle. That looks good to me. Then you have two split out bodies. Awesome. Okay, let's step back before that a little bit. And I have to come in and do... Ooh, let's do bottom before top. So that I can come in here and do the whole pattern based on the control sketch. Extrude boss. We go from this plane. We use a line from here. This one I'm pretty okay with using extra construction lines because this one sketch is going to be is going to be doing a lot of heavy lifting with regard to controlling all of these points. Because I know that I want it centered. Hang on, control that properly. I know that I want it centered with regard to the board, but I'm also making some assumptions right now because I can't really measure the true position of anything. So we'll use that control sketch, and then I'll draw single features that define where I'm putting fasteners for this. And we'll stand it off by, I don't know, 5mm. Whatever seems right. So I'll call that sketch good, and this is the... Oh, don't actually extrude anything. This is just control sketch. This is the DPS5005 hole pattern control sketch. So now, exit out of that, and from that control sketch, I can say, okay, I would like a single circular extrude. Well, it's going to be a regular extrude, but the shape will be circular. Say I want it to be, whoops, come on, circles. Say 10mm in diameter. That's probably fine. Maybe even a little smaller than that. Well, it can't go so small that it causes extrusion issues, so we'll extrude that up to 6mm. I have room for that? Yeah. Yeah, there's enough space around all of them for even 12, I think, so 6mm is probably fine. I am going to adjust this control sketch a little bit, make that stand off a little more. Maybe 4mm instead of 3. Just because I want a little more room between the posts. Gotta let the posts breathe. Old Wizard. And we say it's going to be an M5, so I want to be that minus probably, quarter of a track, so 0.1 on the radius, so 0.2 in the diameter. So I want to be 4.8mm. Draw sizes, 4.8 positions. Well, I don't want it to be right in the center of the circle. I would rather it be coincident with that point. The music got real quiet for a bit. Type, not up to next, but blind. We'll say D1 of boss extrude 4. D1 at boss extrude 4. Minus 2mm. God, it won't let me enter the equation. We'll say 7 for now. Because I do want it to be sort of embedded a little bit, but not too embedded. Ooh, custom sizing. Flat bottomed holes? Yeah, no reason for me not to have flat bottomed holes. Okay, so now we say equals D1 at boss extrude 4 minus, or no, plus 1mm. So it always goes a little bit deeper. And I can tell this one to be just straight up be 30mm tall, and this surface will always be a little bit below. Take a quick peek at what that looks like. Yeah, because I do want it to have a little bit of space, but we're never going to need that much, so, you know, cost benefits. Turn the music down just a hair. Okay, it doesn't actually need to be 30mm high, it does only need to be 6. So, now that I have the whole pattern, I can say DC36V-5 mounting boss and M5 DC36 mounting hole. I'm just going to call it the DC36 in here. Save myself some typing. We'll call this the pattern sketch. Concise names are nice if you don't have huge models. Now, sketch-driven pattern. Ugh, my eyes. Pick the sketch first. It says, okay, what do you want? What features do you want? I want that boss, and I want that hole. Cool. There we go. And we can add whatever features or size changes we like, and it does it all automatically, and you don't have to think too hard. And you can just add other stuff to the sketch too. So like if I put 4 random points or a handful of random points around and I said exit sketch, puts all those in for me. But of course I don't want that because that's silly. So not that I'm against being silly. I'm very much in favor of being silly. But it has its place. DC36 mounting features. I could probably suppress the top closure for now, and it shouldn't break anything. Still need to be before the split, though. It occurs to me that I might actually have just, like, straight up come to the conclusion of this, because it's not super complicated. I've only been going for 50 minutes, though. It's sort of... There are other things I could do, certainly, like, perhaps it's important to, well, I'll need to bolt it together, for sure, but I just don't quite know how I want to do that yet. So what I'm going to do, this is now going to be the, whoops, hang on, that's too narrow. Closure master part. Whoops, cancel. Closure master part. Temporarily rename document. Yes, please. And please stop asking me about this. There are no references to this part. My pronouns are do not reference me. Okay, that seems okay. But before I just call them that, I think it's important to see if I can split this using that. Let's see. Oh, you know what? I can just do a save bodies. Yeah. This one is going to be enclosure left. I'll call it half. It's not really. Ooh, better yet, left shell. Closure, left shell. And I don't want it to consume the cut bodies because that makes it difficult to work on later. Enclosure, right shell. And it takes a minute to sort itself out. You say OK. It's got to go make new part files. Rename them. So we'll leave this behind for a moment. We've got the other two open, so now we'll make a quick assembly. Assembly millimeters. Ooh, this could be a pain to put together. If I clamshell it sideways. Yeah, it'll be impossible to screw some of those bolts down if I clamshell it sideways. Whoops. I can do the left in like a couple of different clamshells. And if I'm careful about the way that I cut the pieces together, it could still work. Problems to solve later, I think. This is just broad strokes. So, left shell. I'm gonna float that. I always do origin mates on the base part. Gives you a nice, good reference frame. Oh, hey, we're almost done with Heavy Light. Next up is their single, Astral Planes, and then it's Wilt from Via Luna. Gray background. Yeah, I mean, when I'm at work, I usually remember to set it to plain white, but I don't know. I kind of like gray. Okay, so insert right shell. This one's already floating, so we're going to mount those both to the origin. Everything mounts right up. Cool. Make those transparent for a bit. Oops, set transparent for a bit. And the DC36. Let's see. If this ever gets more accurate, I want that hole to go there. Gotta look through the part a little bit. Come on now, mate. Dang it. Okay, surface. Cylinder, cylinder, cylinder. I mean, yeah, but my favorite that I put together a little while ago, I'll show here in a sec. Bisexual lighting. That's not... It's a real thing, too. Hang on. One of my favorite Wikipedia articles of all time. Bisexual lighting. A 3D rendering of a skeleton showcasing bisexual lighting. Pink and blue. You do love to see it, but... hang on, let's go back to... There we go. Okay. My problem mostly is that my plain white... I really should mess with it a little bit and get it so that it doesn't wash things out so much, but the default lighting conditions just make every model look terrible and glary and hard to look at. Hence the rather boring gray. We'll call this the master assembly. Who needs part numbers? Got the DPS mock now. I think I'll just have to sort of make this into place as I go. Yep, that looks good to go. Okay. Now, the big question, when I insert this power inlet module, is it going to ruin everything? Yep. Okay. Cannot insert that. Don't want to put educational parts in my parts. That's just awful. Gross. Well, time to replicate it, I guess. It is 17.5 deep. 46.9. Blech. It's annoying. 46.9. Make sure we're in millimeters and not inches. It's 27. Chamfers. 6. Point and done. And fillets. Oh, it's not a fully 3D printed power supply. It's just a shell for one. Like, I've wanted to have one of these power supplies for a while, and so the objective was, okay, I have all the parts. I don't have an enclosure for it. I don't want to buy one because I have access to my own license to SolidWorks. I can do this on my own. So I figured, why not design a complete sort of design the whole kit and caboodle from scratch. So here we are. These are 40 millimeters apart, and they are, hang on, 4.5, what? Hang on, how far is that from that? Center distance, oh, that's all kinds of weird. Is it like a nice round number on the outside at least? This is actually a fairly common project as near as I can tell. Like, a lot of people have made 3D printed cases for these sorts of power supplies, but, you know, I can't just not do it myself. What am I supposed to do? Download someone else's thing? Nah. Oh, hang on. Oh, it's all sorts of weird and round and gross. What have they done? Whoops. What did I do? Whoops. Open the case. Okay. Why is this? Oh, it's backwards. Okay. Sketch on the front plane. Yeah, all it is a case for a power supply. I am not clever enough to design all the rest of this stuff, so. Hang on, what plane am I sketching on? Oh, you know what? Let me turn on the stupid... Okay. I think... No, I'm still in. Still got my assembly shortcut, so it's not going to make it easy to sketch things. But hiding sketches by default is really grimy. Like, come on, guys. We're better than this. Ugh. Oh, and it's all sorts of out of whack, too. Okay, collinear, collinear. I bet we're going to find some nice round dimensions. Oh, you know what it is? Is it in perspective or something? It is in perspective. Why is it in perspective? Hang on. Perspective. You display perspective. I was wondering why that was so suddenly awful. Sketch, Shift P. Oh my goodness. Terrible. Let's switch to... hide that. Hidden lines removed. Oh, yeah, convert entities, offset entities would also work. Psst. But, I mean, this gets the job done. Oops, hang on, why? Oh, it's coincident with the origin for some reason. Which isn't anywhere near the origin of the part, because why would it want to be? Okay, so. There we go, there's our round number. 57.9 and 50. Cool. I guess these are all 4 millimeters. Okay. And how thick? Thick with several Ks. Exit sketch. Don't need to be in the sketch anymore. Come on, let me just pick the stupid surfaces. 2 millimeter thick faceplate. Or if you're on the chunky part, 3.2. I'll just do 2. Extrude boss on the front plane. And it is... well, for starters, give myself a midpoint to mirror about. Ooh, I can actually double mirror this one. Yeah, double mirroring. Love getting a double mirror. And mirror. And just deselect that one. And mirror. Oh. Screw you. Come on, 50. I think it was 57.9 the other direction. And that for some reason decided to not be on the center line. Thanks. And these have 40 degrees between them. Yeah, we'll get rid of that point because it doesn't need to be there. Exit sketch. Extruded boss. Roll 7 to get myself into a... oh, no, come on. Come on now. There we go. 2 millimeters. And then fillets. And then we have a sufficiently open source mock-up. Edge loop. Cool. Call this the power module pretend. And it still wants to save power module mock. It still wants to save in the wrong folder, so I've got to navigate off to that. Hang on. Okay, I thought something was funky. I saved it inside itself. Inside a subfolder inside itself. So I'm just going to quickly open that and tell it to cease to exist. Oh, whoops. What's open? Oh, that one is. Don't save. Yeah, no cursed educational licenses for me. Yeah, that's frustrating and silly, but what are you gonna do? So now we have the power module mock. Quickly made those up. Grab the end face. And then the mating face. Cool, yeah. There is actually quite a lot of space in this thing, isn't there? I could mount the ESP kind of upright against the wall here so that the micro USB was sticking out of the top. And that would make for a really nice... like, sort of data and controls interface right on the top. Or, you know, I could space it out a little bit and have it on the backside. I almost want to put another wall here, so I think I'll do that. Oof. Ate a lot of poutine earlier today, and it is showing itself. Level 7, get myself in a nice orientation. Did I not? No, there. Okay, there's the master. Initial walls. So this isn't going to be actually this long. It'll only be, like, what I'm going to do is instead of making that coincident there, bring it back and say you're now going to be, well, I'll have to figure out how to mount it because obviously there's no real provision for mounting this guy, unfortunately. It's just going to be a bit of a pain. It is, however, 5 mil thick. And rather than being symmetrical in some sort of strange place, just drag it out into the void here a little bit. Have myself a think. I want it to sit back a little bit from the wall. 5 millimeters or so seems fine. Because I have to be able to get to the port on the end, which will be the tricky part. I want it to be far enough this way that it's away from the 120 area, but far enough this way, and also far enough this way that it's easy to get the comms wires over to it, and maybe leave enough space for the JTAG port or the SWD or whatever it's called for STM32s up top. So we'll, for now, I think I will reposition this to be maybe 55 millimeters there-ish. Space everything out. Hang on. Go to the other side. Come on. Come on now. There we go. Make this an actually readable dimensions diagram. Who would ever want such a thing? Wow, that's way more readable. Ought to do that sooner next time. Yeah. Okay. So now I've got some separation, some area for where I plan to put the ESP. I need a little bit of separation. Let's see, let's do that. I guess I'm gonna do it in the wall sketch, but quick trim of that guy. Add a line back there. Make a construction and equal to one somewhere else. Say this is, I want this gap over here to be pretty narrow. Like, the board should be fairly tight. Oh, and then I can use the positioning of the power module, or the power inlet module, to sort of, whoops, what? Oh, I mirrored everything instead of making it symmetrical. Okay, Alt-S, symmetric rather. That places that somewhere nice. Ooh, what? Why is that suddenly free? Oh. It's free to move up and down now. Right, because I no longer have a nice solid line. Okay. Select midpoint on the outer wall this time. And the origin, and say horizontal. Now we're all squared away. Part seems to be coming along well. That's nice. Let's do... Oh, man. They just don't make these things for mounting anywhere, do they? They want you to put them in a breadboard. I could do that. I could... Ooh, that's what I could do. So if we take this style header, that's just sockets. We pop this in here. Say, okay, I'm going to solder this header to the side of the ESP. I could design a pocket that this slides down into, like right here, that using snaps holds the ESP into place with these pins, or these sockets rather, facing outward. They would protrude a little bit unless I was careful, but I can be careful. Probably. There's enough space either side of the pins. Hold that up somewhere so you can see it. There's enough space next to the pins that I could just hold like either side of the pins pretty well, I think. So I have to come up with a cutout. It's got to drop straight down. Oh. Full license to SolidWorks is because I wanted to, basically. I had the time. I mean, my full-time job is as a mechanical engineer, but I like using SolidWorks enough, and using anything else was a deep-seated, cause me visceral pain. And I had, at the time, some aspirations of doing sort of contracting work, so it was like, well, there was a deal going on at the time, so I thought, well, this happens to be a convenient time for me to do it. So I set up an LLC to purchase the software so that I could save income tax and have some sort of like proper structure around it. And then it was like, all right, let's buy myself a license of SolidWorks. I don't really like using an educational version because, I mean, obviously it's hard for me to monetize this. I'm playing copyrighted music, but if I have my own full license, I can contribute to open source projects in a way that makes sure that I will never inflict some licensing problem on the project, and like I have all of the tools available to me. There's no real restriction. Yeah. Yeah, no, that's basically why I don't do it and why I have the license, mostly for fun, because you can't. I have a CSWP. I've been doing this for 5 years, and I work in IT, and I'm pretty darn good at this, all things considered. But nobody wants to pay $50 an hour for a guy who really knows what he's doing versus the guy who says he'll ask for $5 an hour, who lives in a place where he can kind of live off that. I don't live somewhere where I can live off that, really. So, and I don't want to work for $5 an hour. I'm not gonna work below minimum wage for my skill set. And of course, I kind of suck at advertising that too, and have no interest in spending the time to go and do like Google Ads or something. Maybe I will eventually, but not just yet, for sure. Anyway, what was I doing? Okay, before the save out bodies. I got messages. Yeah, full automated. Come on now. $100, a machine design for $100 is not going to be. No, come on now. They're not going to do FEA. They're not going to check anything. They're not going to do hand calcs. They're not going to do anything that would allow you to legally sell the machine in the United States. Like, you can pay them for that, and you'll get a model, but no. And you're not going to get files that are usable. You're not going to get. It's a long, long list of things that you are not going to get for $100. Like, I designed a couple of pieces of aluminum epoxy together in the United States, and I mean, maybe this says more about how expensive it is to have things manufactured here, but $75 for, I think, 4 or 5 pieces of aluminum angle epoxy together with 10 holes in them, so. That's actually a good idea, yeah. I've thought about doing that, and I just sort of haven't gotten around to it. I have enough work at work to keep me busy, and I get paid pretty well at work to stay busy. And when I'm doing this sort of stuff at home, I prefer to do it for fun, so. Whoops. Although, maybe if you had something really interesting, maybe you could convince me to do that, but it's a tough sell for me. Where was I? Okay. ESP mounting. So we're going to do an extruded cut. So I have to have... I really should have calipers to do this. Yeah, okay. What I'm going to do is I will come over to this side. Onto this on this base, I will draw. Let's see, show me the control sketch. I'm going to draw a pair of pants. Cosmic pair of pants. That does not. Okay. Ooh, there we go. Okay. Midpoint. And there. Yeah, I'll probably do that at some point, but this is just sort of planning cutouts, so skip that for right now. Make this collinear up here. Ooh, better yet. Rather than defining the edge, which might change, well, I go back and forth on where I want to define sort of my references and sketches and things. Collinear is fine, but you can also do collinear to faces and that sort of thing. Certainly I'll need at least, whoops, pinch my fingers with the tape measure here. Probably at least 5 millimeters for the waist of this pair of pants. Oh, we'll go like 8 and have it stick down a little bit. Oh, that's not right. Come on now. No One Cares, one of my favorite songs by Violina. And it also occurs to me that we are almost out of music, so I gotta spend a minute, glance into the mind palace of Clark's bizarre music taste. Come on now. What do we got? Ghost City is great. Oh, goodness. Ooh, Dawn Bombs. Yeah. Hang on. Add to queue. Add to queue. Add to queue. Add to queue. Oh, hang on. Wait, I did that in the wrong order? Yeah, hang on. Remove from queue. Remove from queue. I try to do it in discography order. No! I skipped. Oh, damn it. Hang on. Accidentally skipped to the end of No One Cares, which would be very disappointing because I like that song a lot. Okay, add to queue, add to queue, add to queue, add to queue. That'll get us another hour or so, which I think will take me to the end of the workout I'm doing this. So now I have to. I mean, I could. Oh, you know what? It's going to be a round number of inches, the distance between these sets of pins. Because the spacing is going to be point something inch. Probably. Don't I have one in a... Hang on. I have one of these. Last time I was messing with an ESP, I was doing servo messing around. So that... Oh, goodness. Maybe that's not a nice round number of pins. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, no. It is 0.9 inches from row of pins to row of pins. So what we'll do... Oops. Make these two right length. Mouse over them until we get the midpoint. 0.9 inches. What? Oh. 0.9 inches. That's not vertical for some reason. Vertical. Come on now. Yes, that's correct. This is... I guess these should be probably 0.1 inches wide. Which means they're going to look pretty close to 2.5 millimeters. But I want some space, so say 3.5. Wow, that's pretty narrow. I hope I can fit into that. And it comes down about... I guess that's probably going to be in inches. Rude. 1 and 1 1/8. So I'll say 1.2 inches. Mm-hmm. 1.2 inches. And then the pins will poke out right on the side here. And then I have an easy way to reprogram the ESP that is programming everything else. Probably. Assuming I do this next bit, right? So now it's got to be a minimum of 5 millimeters past the... Whoop. He's throwing stuff. Extruded cut. We want to go equals thickness at control sketch plus 5 millimeters. So it'll always be 5 millimeters deep into the part. And that should fit okay. So now I need... I am gonna eventually end up grabbing an ESP to do this properly, but it's kind of fun to wing it every once in a while. Yes, Dawn Bombs. Yes. A friend of mine introduced me to this band. Some friends of his from Bellingham. And it's just so groovy. Oh my goodness. Ugh. Okay, so we're gonna be... Left along the low hard sortie. I'd like to be the one you wake with in the morning. Your sheet above enveloping. Okay, so castellated section, 16 millimeters across. I can be 1.5 millimeters wide, and I have to have 17 millimeters between. So we'll say this. Street boss from this guy. Who's the least boss? I've never flown so high, but I'm accustomed to these lows. Whisper love into the ash we blow. Fire and glass, and finally you two know. Me and her bending party. Come flying me, sorcery driving me lazily. I gotta be the height of the micro USB to keep it from running into anything. Which is like 2.5 millimeters. Whisper love into the ash we blow. Fire and glass, and finally you two know. That's right, this is a singing stream now. How far do I want these to go? Can I get this? Oh, goodness. I got extra messages. Ooh, do such a thing. We are 34 millimeters long. I should have remembered that from earlier. So let's just extrude this like 30 millimeters. To glide by, attempt to pollen, temptation, conversational you. Some sort in mind too. Okay, is this actually only 5 millimeters high? No, it's not. It's more like 8. That's. Whoops. Hey, yeah. Always glad to have new folks showing up and learning stuff. Like, that's what a RudioCAD stands for. I stream on this channel because it's easier to stream on my own, and I just kind of got started, and this is where people are subbed, so... I do have another channel, a RudioCAD, that's after my LLC, and the idea behind that was form a company to teach people to do CAD better so that I don't have to deal with bad CAD. I wouldn't say it's going great, because obviously I'm not really doing anything with it, but better to have it than not, I think. I wish the best for him, he has it when he holds you, and I said that shit barely seek the truth, and seeks to seek you. Okay, so now I should probably, what's this? We got the DC36 stuff. DC36 mounts and caps. And these are the... Ooh, actually, we'll call this the ESP pin cutout. We'll call this the ESP standoffs. And now we're going to do some really weird stuff. We're going to put a plane in the middle of this. I wish the best for him. We're gonna do. This isn't gonna work well at all, but I'm gonna print it anyway, and we're gonna see how it goes. Well, I'll print it eventually. We'll see. See, I want to sketch this plane. I want to be normal. I do want to be normal generally. I fail frequently, but. What about an airplane? Oh, yes, we're putting an airplane in the middle here. Broken glaze prerequisite to see the end. Love this album so much. Well, this EP, it's only 3 songs. Evergreen Means, the last song was Monday Rose by the Non-Bombs. Such a good album. It's just so freaking groovy. Never miss an opportunity to tell someone to listen to it. Okay, so I've got... Let's see. Hold it end on here so you can kind of see... okay. Whoops, I got that backwards. Okay, so we've got the... Yeah, you aren't all the viewers for the first time in a while. So we've got the micro USB on this side, on the side of my finger over here, and I want the micro USB to also be over here in this spot, so that it's sort of on the more outside side. And the pins will come out here from where you'd expect them to. And we'll have clips sort of pressing the thing down using spring magic. I'll figure it out. And I just have to figure out how exactly I want to do those clips. Oh, you know what? This actually would make a perfectly fine clip structure if I stretch that down a little bit and then it would press it back against... Oh, that'd be so weird. It'd be really complicated, but I think it'd work. He said right before designing something that won't work. Invariably, every time. But I do want to show off, I want to show sort of what I have in mind here, so. Okay, so 90, I come up. M equals... I'm just going to assume that you're struggling with the TV keyboard because... Oh. Weird M equals. What? Yeah, you're going to have to help me out here. Mostly by... speaking something clearer. I want... Let's see. This guy should be horizontal. A lot of this stuff is not properly constrained. Okay, so the board is probably some standard PCB thickness that I don't know because I'm not electrical, but looks like about 1 millimeter. So I will plan for that minus maybe 0.2. We'll say 3/4 of a millimeter, and say we've got a 0.75 gap here. We'll draw a line there so that we can center everything. When fitted together, these have stick-outs of approximately more than is convenient. M equals 7. 7... What is 7 factorial? 7 times 10 is 70, times 12 is 70 plus 40 is 840. Is that right? No, hang on, I'm missing 6. No, wait. Oh, no, it's 840 times 6, so it's 40 plus 240. So it's 5040, I think is 7 factorial. Now I gotta check. Why are you gonna do this to me? Yeah, 5040. Cool. I can do factorial in my head. Kind of. Yeah, Dad, you should come tour my work at some point. Or no, you did do that. Come tour my work again. It's cool. Well, actually, wait a couple months and then come tour. We'll have more cool stuff. Oh, those stick out quite a bit. Those stick out 2 millimeters. Oh, goodness me. The wheels are too big. The wheels will be much too big. Okay. So we got kind of a structure doing structure-y things. I'll just make those concentric. That's fine. Well, no, I shouldn't do that. Don't do that. Lazy Clark. Jerry, John, Jerry. Jerry's obviously my dad. John is our electrician and knows a lot of things that I don't know. Let's see, let's see, what's constraining this or not right now? Okay, that does not have a width constraint. Probably has to be at least the width of the pad. It's like 1.8 millimeters. Oh, we make that easy. Okay, so this has to be some minimum distance so that I have reasonable thickness here. So we'll say 3, just because we're doing wild guessing game time. We'll make this guy. It's always gravity. Gravity's always getting in the way. And I have to come up with sort of a respectable flexure distance. Centimeters probably fine. Whoa, whoa, whoa. Plenty of exclamation points. Exactly the right number of exclamation points. And it has frozen itself. For some reason. 6-ish is fine. Now we say normal again. I'm just going to draw this off the existing geometry. I don't care. Whoops. Actually, I do kind of care. I care just enough to kind of have to do it right. So now we mirror it. Say feature, extruded boss, 12, midplane. There we go. We got a clamping structure. And that will clamp an ESP in place. Possibly. Into my own veins. ESP clamped midplane. And this is the ESP clamp extrude. So that's pretty much all the interfaces that I need. Is this still split alright? Yep. Wow, I've been going for 100 minutes now. Who messaged me? Who would do that? Random stuff. Okay. Ooh. My splitting Karanga. Oh, that's gross. 22.5-ish. Yeah. I hope I'm doing a good job. I mean, you did manage to... Wait, no, you managed to draw a 3D box that you could make a weldment from, which is an achievement, and I could not do for probably the first 3 years because I just never needed to draw weldments. And they're tricky, to be fair. Weldments are a pain. Especially 3D sketches if you're not careful about when placing sketches and how you're controlling things. It does need more USB-C. I actually... Hang on. No, I thought about, for a little while, I thought about getting one of the lower powered ones and using one of these USB-C to 20 volt, however much current your power supply will spit out, And maybe I'll do that down the road as like it's like an alternative thing, but who knows? This is true. Electrons are probabilistic, kind of. I mean, it's like everything. Everything's a wave, right? Everything's a wave. That's what I half remember from my physics class. I'm glad you think so. Certainly I'm going to need an electrician to tell me all the stuff that I'm forgetting and forgot my EE215 and Intro to Electronics classes. Because, boy howdy, I do not understand how to do analog stuff. Okay, let's... Okay, can I... Let's see, I think I want to do this before the ESP stuff. Maybe even before the cutouts. Yeah, let's go before the cutouts. Oh, that makes that really hard, doesn't it? Whoops. We'll do a quick transparent section. Include selected. Ooh, how far apart are those two? Distance 4. Okay, that's fine. Oop, that needs to be 2 and not 4. All concave. That's probably too many. 53 adult children. True statement. Oh my god. Okay. Just gotta deselect all these extra ones that I grabbed. Oh, come on. Come on now. What? Not want to let me select the... Oh, because they're still kind of transparent. Okay. So we'll disable this, and then we'll come back and do the fillet. Nah, it's fun to have a peanut gallery. You gotta have someone, like... You have to have someone flying around in the background, you know? Okay, so now we've got... Fillet... Interior fillet A, because I like to use letters for mine. Then we come down here, we do all our cutouts. Nothing breaks! Stayed for the dad joke battle. Oh god, I should make a t-shirt out of that. I'm still on the hook for the Hot Pot Pie Summer, though. Hot Pot Pie Summer one, though. That's on the to-do list for sure. Okay, so... Got interior fillets in places that probably won't cause problems. I've got M5 compatible pockets. I think maybe I want to shrink those just a bit, though. In any case, I do need to group up all these cutouts and... Yes, whoops, no, do not... Oh, wait, what is that? Feature properties? Oh, interesting. You can add created by to your features. That's not doing anything, but it's like allowing someone to blame you later, I guess. What do I want to call this? We'll call this the ESP interface features. Ooh, cutout features. I like to do it. It's not super critical, but mounting app features. I like to have my folders explicitly be named something features so that I can always reuse. Like if something really makes sense to call it this is the something cap. There is actually a cap feature for weldments, but it's a good way to avoid Hot Sat Doodle 1. Please enunciate. Hot Pot Pie Summer. We had pot pies on a hot summer day on a Wednesday at work in just the middle of the afternoon. It's pretty top quality, all things considered. Actually, irrespective of all things considered, it was great. Caffeine Calypso. Yeah. Anyway to say, after all we really do display the kindness Avoid caps, yes. I mean, I have seen it in some cases. Come on now. If I was really clever, I would design a cap to fit in here, but that's probably a half-hour task in itself to design and fit a cap into that. So, for now, I think I have a good basis. Wait, no, hang on. Ooh, here is an interesting situation. I'm going to put in a feature that's going to break something later down the line, and I'm going to show you how I fix it. So, exterior chamfers, I like those generally. They're great for making clean-looking parts. I need to quickly figure out side length of an hang on, no, wait, that's dumb. I'm just going to guess. Can I quickly draw some lines? Lines. These won't actually work. The reason I'm not showing anything. Avoid apps. Use them just in case. My god. Utterly incorrigible. We'll start those at 2. We'll call that exterior chamfer A. And when I drag this to the end, it's going to break something in interface features, or it won't for some reason. Hey, did I actually do that right? What is this? What is that coincident with? Oh, it's coincident with an edge that no longer exists. But it's not complaining. Why is it not complaining? Control-Shift-Q? Nothing? That should break. Why is that not breaking? So this... Oh, hang on. Well, it says it's not broken, but it should be, because it's going to a line that no longer exists. So instead, I'm going to break that collinear constraint and add it to the face instead. Because chamfers create new faces in between other faces, they don't actually change the base faces that you're working with, which is super handy when you want to like add chamfers or fillets down the line and make sure you don't break anything. That's, I don't know, that's my job, is figuring out how to not break things. Oh, I was going to do a quick check. I want this to make a nice a chamfer coat. Bring that from 2 up to maybe 4. What's the minimum distance here? 5 millimeters? How are we doing? 5.07. I could figure out what that's supposed to be to make that exactly 5, but I think I'm okay with calling it good. So, printable as is. Well, probably not. Let's go back and take a look at this with a little more context. Hey, check that out, we broke some 8s. Que sera. Que sera sera. Hang on, is that the title of a song? I feel like I'm being messed with. Or I'm just forgetting things that I said 30 seconds ago, which is equally probable. Okay, so, everything... If I look at my module... Steam... You know, if this slides over a little bit, that's actually just in the right spot to keep everything on this corner. So many fish fillets. A fish, but like looking chamfered, feels very Minecraft, I think. Okay, so we've got... Blazed sacred sun. Whoa. Yeah, so we've got, hang on, let me see if I can orient everything correctly. Nope, okay, it's like this. So we've got AC coming in this side, which corresponds to roughly here-ish. We got DC coming out the bottom, down here, out of these terminals, these ones. And that's coming out right here. And that keeps right here, which is the transformer and kind of the isolation line, which John has helpfully drawn on the back a couple of days ago when I was asking about this guy right here. You can see that. That ends up in kind of the right spot to keep all the low voltage DC on this side. Yeah, probably Daleks. It's always Daleks. Whoa. Oh, mind. That's the end of the song, so you don't get to say whoa whoa anymore. Darn. I can't leave this. Hang on. It's, I have to figure out. This is gonna look really silly, but I can't just not know what the correct fillet distance is here. Everything is right here. Oh, there's a really good song that I'm trying to remember the title of, but now reading that message I can't remember it, so... Oops. Hang on, how is that one defined? Okay, make those equal. What is this length? 4.1? Is that like... Okay, hang on. What does the measure tool give me? 4.1005. Hang on. 4.1005 divided by square root of 2 times square root of 2? Man. Educational channel. I mean, I could change it to say not educational. There are no rules, it turns out. Well, except the terms of service. Probably shouldn't violate those. Then everyone would have to go find me over to RadioCAD, and it'd be a whole nothing, because nobody watches it. Well, 4 or 5 people right now watch, but... Dull emotional support, yes. Oh, you know what I should do? So... My head obscures some of the chat, which is probably fine, because you can also see it, but it does give me the opportunity to redact things, which I guess is good. Gives me some time. But I'm not redacting anything. There are no rules. Okay, so this is 7. How is this determined? Like this... I want to write an equation that exactly defines, based on my other parameters, a chamfer that gets me a perfect curve, and yet also a chamfer. I'm just... That's not worth putting time into, right? I'll just make that 4.1005. Do a quick check. Whoops. Do a quick check. 5 millimeters. Good enough for me for right now. I'll come up with the equation later. So I guess I could draw a sketch that just sits randomly in the background that is like hidden all the time, that perfectly calculates where it needs to be. Yeah, I think that's all for tonight. Thank you all for coming. What? Good night. Okay, yeah. I think there's just, I'm watching my own feed to see when I look up at the camera and look off to my screen on the left, because it seems like there's about 15 seconds, yeah, roughly 15 seconds of delay. So, yeah, thank you for coming and watching. Like, subscribe, all that fun stuff if you feel like it. Tell your friends. If you have someone who you think could benefit from this, or wants to spend their Wednesday evenings watching someone stream SolidWorks sort of aimlessly, please point them in my direction. I am always happy to continue teaching people how to do stuff better. So, yeah. Turn the music down. Yep. Always a pleasure. Thank you for coming and watching. That is all I've got. Boink!